Hello everyone, we are in chapter 1, moving on to learning target 4. We're going to do the distance and midpoint of segments. So you can choose to or not to use graph paper to help you with this. I don't care which way you do it as long as you can do it. So let's just talk about the midpoint formula. Now you're not going to see this picture on your note sheet, I know that. This is just to show you where the formula comes from. So let's say we have two random points on a graph and I want to know where the middle is, the midpoint. So the midpoint is the point that bisects, which means cuts in half, a segment. So let's just pretend these were any point. I really just want to find the middle. So I can't count diagonally, but I can count horizontally and vertically. So if I count horizontally, I can easily find the middle of there. And that's by taking the average of the two x values. So x plus x divided by 2 is going to give me the middle here. And then same thing with the y. I can count vertically, and I can do y plus y divided by 2. Now again, you don't have these numbers, that's okay, I'm just showing you how it works. This is what you should be writing down in your midpoint formula. So now let's see an example. So on the bottom of your notes, you should see this example. So again, we're going to use the formula. The midpoint formula is x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. It should be in parentheses because it is a point and a coordinate has to be in parentheses. So you can either choose to do it the graph by counting your vertical distance, finding the middle, counting your horizontal distance, finding the middle. So right to the middle is 1, 1, 2, 3, 4, 5, 6, 7, 8. The middle is 4. And then you find that coordinate, so 4, 2. Or you can plug your coordinates into the formula. So 3 plus 5, 3 plus 5, x plus x divided by 2. And then negative 2 plus 6, y plus y divided by 2 gives you 4, 2 as well. So it doesn't matter which way you do it, as long as you can do it. Distance formula. So again, I can't count horizontally, or excuse me, I can't count diagonally. So I can't go, 1, 2, that doesn't work that way. But I can count horizontally, like I know this is 1, 2, 3, 4, 5. I can count vertically. Oh, screen's going black, that's okay. So I can count horizontally and vertically, but I cannot count diagonally. So if I keep that going, I can enclose this to be a right triangle. So I can use Pythagorean Theorem. So with a squared plus b squared equals c squared, remember c has to be the hypotenuse, so that's what I'm trying to find. I'm trying to find the distance, the length of this segment. And the a squared and the b squared are the changes. If you notice, it kind of looks like slope. So it's the change in x and it's the change in y. So that's where your a squared and b squared are coming from, the change in your x and the change in your y. And then to solve for c, you would take the square root of both sides. So you would have the square root of this whole thing. That's your distance formula. So under distance formula, you're going to put this guy. That is your distance formula. So now you can either, again, plug these values into your distance formula, or you can use the graph to solve for this, whichever way you want to do it. So you can choose to connect it in a right triangle and then say, okay, 2 squared plus 1, 2, 3, 4 squared is equal to c squared. Solve. You get the square root of 20, which simplifies to 2 radical 5. Or you can take that formula, substitute values in, so you can say, okay, x minus x, so 3 minus 5, negative 2 minus negative 6, be careful of that double negative. Substitute that through, and you're still going to end up with the radical 20, which simplifies to the 2 radical 5. So again, I don't care if you do it on the graph or if you use the formula. I will not be giving you the formulas, so you do need to know them. As long as you can do it, we're good to go. That's it. It's a super short and sweet video. Have a wonderful day. I will see you in class.